In our second example, we're going to be looking at mortality or death. We will be looking at a score that is used for patients over the age of 12 that are on liver transplant waiting lists. This score gives an estimate of the 3-month mortality for patients and is one of the factors that determines how quickly the patient might get a liver transplant. This is the model for end-stage liver disease, which produces what is called the MELD score. We will once again compute the MELD score for an example patient by hand. Here we have a 50-year-old woman who has lab studies showing a few lab results which we will need in the model. There are a couple of new features about this model that make this more interesting. First, notice that the first feature is not just a lab value, but is the natural log of that lab value. Similarly, for the other two lab values, we're taking the natural log of the values before plugging them into the model. Using the natural log of the features instead of the features themselves is common when there's reason to believe that the relationship between the risk and the features is linear in the natural log of the features. The second thing to notice here is that there's an intercept feature. The value associated with the intercept is always 1, so we can think of the intercept as the expected risk score if all of these values are 0. Now let's compute the MELD score for this patient. First, we enter in the natural log of the creatinine value to get natural log of 1, which is 0, and we multiply that with the coefficient value to fill in this column over here. And we repeat this with the other two lab features, and we already have the intercept, and we sum up this column to get a score of 1.01. For convention, this score is multiplied by 10 and rounded to get an output MELD score of 10. Note that a score of 10 isn't directly telling us the probability of survival at 3 months, but is informative when comparing to the MELD score of other patients.